Welcome to IA 215. We are now in week 3, and we are now starting to talk about how you develop one of these work cell projects from the beginning. We've talked a little bit about this already in some of the introductory presentations. In the classroom, in lab, we are starting to collect all the components and remind ourselves how to use those components like PLCs, and we'll be diving into robots and vision systems as well. But now I want to talk about identifying and justifying automated system opportunities. And I've put together a little presentation. It's not got a whole lot of other information in it besides just sort of the titles. And in this presentation, we're going to basically have this agenda. We're going to talk about identifying, that is, your automation targets. We're going to talk about using kind of an initial justification process, talk about ROI a little bit. We're going to also dive into using free resources, which is vendors, system integrators, and some of your corporate partners. If you're in a big corporation with a lot of plants around the world, you might find that you've got some free resources if you can tap into them. Another category is called building stakeholder confidence. This is more important than you could possibly realize when it comes to implementing projects. Then we're going to move on to defining success, which is defining your metrics and how to collect the data to calculate your metrics. We're also going to talk about scope, the scope of the implementation. And finally, we're going to dive into making sure that after our initial identification of the project, we can take a step back and ensure that the project's going to work for the whole plant. It's going to work for the whole production line that you're improving. You're not just sort of gilding a turd. You're not making one tiny point in the plant perfect, which will not have an effect on the overall production line because the production line is too stuck. So we're going to take a step back and check that. That's the final step. This is all part of the initial identification and justification process. It shouldn't take long. In the real world, this whole thing shouldn't take more than, say, a few days. Sometimes you might have to go onto the shop floor and gather some data, and that may take some time and extend this process a little bit. But from the initial target of these projects through to the ability to define the scope and metrics and take a step back, that should not take more than a few days of time. This can be done by project managers, plant managers, or it can be done by empowered shop floor personnel or maintenance personnel. So this is a project idea that if this person is empowered to do this, can be done by a variety of personnel. It could also be done by a third-party vendor like a systems integrator. So let's dive into the first topic. The first part of the finding of targets for automation, for robotic improvements, is I call it the walkthrough. The walkthrough is the time when you can physically do this, physically walk around the plant and walk down the different manufacturing lines and observe the operators, perhaps at different shifts as well, but certainly during first shift. Observe the operators doing the various jobs, watch the machines operate, and watch the systems operate, period. And so that's where you would develop a lot of ideas. In addition to a kind of traditional physical walkthrough, a lot of times, especially if you have a larger plant, you would sit down with the plant manager and develop a more high-level view of what's going on at that particular facility and walk through in a verbal way. Maybe not physically seeing anything at all, but verbally going through all the different areas in the plant. Step through from the very front of the plant, things going on in engineering, things going on in quality assurance to the back of the plant. Your raw materials coming in, being stored, your finished goods going out, and every process step in between. Now, in addition to this kind of walkthrough, you can't just do it alone. You can't just walk through the plant. You have to be developing what I call sponsorship during that. And you might be walking through the plant with a supervisor. And as you're doing that, you're listening to the supervisor and you're trying to develop a rapport with the supervisor or the plant manager or the quality person or whoever it is. And you're picking their brain for ideas. And also you're letting them know that their stuff is really important, period. You're trying to bring forward ideas for automation, but you can't do that alone. Nobody can do that alone. You have to rely on them bringing their ideas to you and then bringing their support to you once you've decided to start moving forward on a project or two. I think that sponsorship development is sort of this soft skill that most engineers don't do very well at, most technicians don't do well at, especially technicians, who like to work third shift and be alone and not have to worry about that crap. And certainly I understand that, period. However, we need more than that. We need more than that in our project development. If we're going to be ones who identify these projects and get to run with them, especially if you end up getting a 4-year degree, it very well may be you. So we need to develop that as a skill set. So the key skill set in anything associated with sponsorship is, number one, listen. And number two, document clearly what they're saying and ask questions to be sure you really understand what they said, period. And number three, go back to them and make sure that they get the credit for anything that they brought forward. And we're going to be talking later about sponsorship and how to support that as well. But at this early stage, we definitely want to listen and we want to document and we got to prove our worth, period. So during this process, we also want to uncover the pain. We want to let them tell us where there are problems, where they have problems with personnel, with getting enough people to fill a role, with injuries, with quality problems, with machine problems. That machine is just not reliable. And this can be quite a bitch session. Forgive my French there. But it is also an important time to listen to your potential sponsor. Now, you don't necessarily want to take everything they have to say to heart, but you want to be able to listen to what they say and filter out they're just complaining about an employee or a boss, and spot the areas that are, all right, this is something that's generating a cost to the business or slowing down the business or hurting the end customer in the quality of what they're getting or the timing of what they're getting. So that filter is critical. And I think it's critical for everybody involved to add into this list. So you might have a develop initial list of pain from one supervisor. You may want to gather that same list from operators on the shop floor, the plant manager, and even perhaps the plant controller. plant controller is the guy who is responsible for the finances. So in the end, his pain is probably going to be of extremely important interest. I think I want to also mention stealing ideas. And when I say stealing, I don't mean not giving somebody credit. I mean, look at the ideas that you have in your sister or brother plants. Look at ideas coming out of lean manufacturing concepts and all existing projects, period. A lot of times when I was involved in major implementations across several different plants, I would throw out an idea based on an observation, and I would hear immediately, quote, well, we did that already, or we tried that already, and it didn't work, unquote. And so that can sort of make you feel less likely to bring the idea forward. But a lot of times, great ideas are ignored because the plant manager didn't have it presented to them correctly, or maybe the management at the time didn't recognize a good idea. So you shouldn't necessarily throw away a good idea purely because it wasn't implemented the first time it was thrown out there. As you develop these ideas, and you should always make sure you recognize who gave you those ideas. So give kudos to where they belong. That's really important. Especially if it's one of your sponsors. So I would also like to go through what I call the idea sheet. So let me bring out what I call the idea sheet. The idea sheet helps organize the ideas, and it helps prioritize the ideas. And it also helps you collect information, which I think is kind of important. So what I'm going to do is switch the share to my idea sheet. And here's an example of my idea sheet. This is kind of a simple idea sheet idea. And it's in a spreadsheet format. I love spreadsheet formats because hold on a second. The idea sheet I like to use is in a spreadsheet format, and I like the spreadsheet format because it gives me a great way of automatically resorting and managing this, and then I can just add additional sheets if I want to create an ROI or a project justification. Period. So this is an example sheet. The first thing you see on the left is a column saying priority. Priority lets me later on, I won't necessarily put priority in at the beginning, but later on, look at all these ideas and give them a priority of 1, 2, 3, 4, up to 10. You can number them however you like, period. The second one should be a short description of the idea, and I've given you the example. Install a robot to load milling machine 1. The third column is sponsor. This is probably, of all those columns, the most important column. Who is the primary sponsor, the one who really would like to get this in place? The fourth column is plant location, so that we can quickly locate where you are in the facility. If you are working across multiple plants, you might need to add a column for plant. The fifth column is current need. And this is also very important. This lets you hopefully summarize what the pain is, what they need to have happen for that facility to work better, or to make more money, or to be more successful, to produce better value for your customers, period. The next column is future ideal, which is how you would like, not necessarily what robot type or how you want to set up the robot, but how you would like that work to be produced in the future, generically. For instance, my example says, in my future, I'm going to have 5 shifts, all 5 shifts covered with a robot or something so that I can keep that milling machine running 24/7, 7 days a week. For some of you who may not understand what shifts 4 and 5 are, a lot of plants use shifts 4 and 5 to describe weekend shifts, Saturday, Sunday shifts. They're often 12-hour shifts, like 2 12s. The last column, actually the second to last column, is the second to last column is the kind of benefit, period. Now, I don't say savings here. I mean, I think a lot of people who implement projects want to talk about how much money they're going to save, but I don't think that's what we want to use when we talk about projects that are automated projects, period. Saved projects are, projects that are based on saving are not necessarily what we're doing here. We are creating benefits for the business and for potentially the employees. So it's not just about savings. It's about improving the business. Now, in this case, we're talking about increasing the overall capability of the manufacturing line. And by doing that, we can get more productivity, which means we can produce more product, which means we can produce more profit. And the last column would be a rough estimate of the amount of additional profit we could produce. So if I can now run third shift, that third shift runs 8 hours, I would look at my products I could produce during that 8 hours, calculate the value of the product minus the cost of the product, and that would give me my benefit, my estimate benefit. Okay, so let's continue on. Now we're going to talk about building stakeholder confidence. We've talked a lot about stakeholders. So now I want to talk about building that stakeholder confidence. The first thing in building stakeholder confidence is do your homework. Period. A lot of documentation is available online for very rapid development. If you haven't already exhausted your resources on Google for everything around the project that you're proposing, then you've made a mistake, period. You also should be able to get real data from the shop floor whenever possible, exactly how long something takes an operator, exactly how many operators there are, exactly how many shifts you run, what the quality really is. And if you have that data, you should have it in front of you and ready to talk about it. You've got to do your homework. A lot of potential projects go by the wayside because the people who implemented them or started to implement them just weren't willing to put their nose down and get this data collection stuff done first. So do your homework, make sure you know all the details. They're going to tell that plant manager or area manager or supervisor exactly how this is going to work. The more data you have at your hand, when they have that conversation with them, the more confidence that you will get from them. And I've mentioned this before, but you've got to give credit where it's due. I've seen many projects go by the wayside because a supervisor who came up with the idea, even if he wasn't the only one to come up with the idea, he came up with the idea, wasn't given at least part credit for it, and then basically shunned the project and made sure it failed. This is not professional behavior necessarily. However, we all know that not everybody at a plant is as professional as they should be. So we have to make sure that we give credit where it's due and support people who came up with ideas, even if they weren't great ideas, even if the idea had to be highly modified to be functional, you've got to give credit where it's due. The last area to build stakeholder confidence is to make sure you start with a small, relatively easy, but hopefully high value project. Don't start with something huge where you're changing over a whole production line or putting in a $5,000, $5 million piece of equipment. 5,000 is pretty cheap nowadays. Period. So the idea is you start with that $30,000 project, one operator, and make it successful, period. Prove that it works, support it well, make sure it's documented well, keep tuning it to make sure it operates well, make sure that any of the mistakes you made, and you will make mistakes, are fixed and aren't lingering on, pissing off operator after operator. So next area is defining success. So we're going to talk about metrics. Metrics are another key area. Developing usable metrics is a critical process. When I say metrics, I simply mean it's a measurement of something that's going on in the shop floor right now. A typical metric might be parts per hour. Some people, if they make parts slow enough, might use parts per day. The metric is simply there saying that I am measuring my process using this number. And most importantly, somebody is collecting the data for that number so that I can pull it up and look at it on a daily basis. A lot of times, plant managers want a metric and they don't have any way of automatically collecting that metric. So then they ask operators to fill out a sheet by hand every day so that they can get their metric, period. This is the worst possible way of collecting data, in my opinion, because it just pisses the operators off and it gives them extra stuff they have to do. And it makes an opportunity for metrics to be wrong, to be fudged, and for there to be errors. Period. As part of this project, I'm going to come up with a list of possible metrics. However, among those metrics, number one, you have production rate metrics. Number two, you have quality rate metrics. How many parts are bad is a very typical metric over total parts produced. Period. In addition to that metrics, we might have injury rate metrics, comma, machine uptime metrics, such as how long does that machine stay operable during the times when it should be operable. You might have overall production throughput rates. You might have quality, I'll call it customer satisfaction rates, depending on the product we're talking about, and so on and so on. It's critical that when we talk about metrics that you pick items that can be measured. A metric that's not easily measured or can't be at all measured with the facility you have is not a metric you want. You want to absolutely find a way to measure automatically, and you have to have a way of measuring effectively, or you don't want to select a metric. Period. A lot of times people have data collection as part of their automated system. The PLC has some data in it, and above the PLC, you might have something called a SCADA system that stands for Supervisory Control and Data Acquisition System. And that SCADA system might collect data as well and have that data in a report. And that data could be sitting out there on your network that no one is using. So the key is, once you find the data, find somebody to help you develop the report to develop your metric properly. And that leads me to the next area, building data collection systems. You have to build data collection for your metric into your plans for your project. PLCs are the best way to do data collection in that sense. You can do your counts, you can do your timing, and you could hold that data. However, the data sitting in a PLC register is of no value at all. So you will need to have some sort of higher level system to collect that data inside of a PLC. In the worst case scenario, you'll at least show that metric through an HMI, a human machine interface. This is probably what we're going to end up doing on our projects because we don't have an integration to a higher level system. But in the better cases, your data in your metric on your shop floor system will be plugged into a higher level system, and your data will be collected automatically. And then you can develop your own reports and metrics and have them automatic. And the last area I want to talk about is buy-in for the metric. If you have a metric and no one uses it, did it ever exist? Sort of a tree in the forest kind of a scenario. And the answer is, it may have in some sort of generic otherworldly sense, but it's of absolutely no value. So you have to have your sponsor, your stakeholder involved in defining the metrics and then recognizing how important they are, and then included in some plant level reporting and measurement at the plant level. Some plants I've worked in the past have developed what they call plant dashboards, where we would have metrics that we would check every day, and they would be reported up in the plant dashboard. And as part of a daily meeting and then a weekly meeting, we would review those metrics and see how we're all doing against our expected targets for how that system was supposed to operate. So you have to get that sponsorship. You have to get that buy-in on the metric, and it has to roll up to where people will be looking at it in the plant, or it's of no value. All right, so the next area we're going to get into is defining the scope of implementation. The scope of the implementation really, that's really saying what you're going to do, period. And the reason why we talk about the scope of implementation is to make sure that you know what you're going to do ahead of time. And we start off with input. You know, what is the input point? Where does this system start? And then we go to output. Where does the system end? In other words, what's the part that you're going to deliver to the next step, the next operation, shipping, storage, whatever it is? Where does this system end? Within the process itself, we want to know exactly what the requirements are. Are you guys going to do 3 steps, 4 steps? Do you want to have flexibility to run one part, or do you want flexibility to run 17 different parts? Or infinite parts, in which case you need to have some reprogramming each time you add a new part. So it's important to really make sure that you've got these input, output, and process requirements clearly set. And as you'll see as we go talk about this project itself, we're going to talk a little bit about sort of the tools we're going to use to collect that information. Now, in addition to the inputs, outputs, and process, we, in any sort of automated system, have to deal with data requirements. In some cases, that's as simply as making sure that the production orders or the process orders come down the pike and are utilized correctly in process. In other cases, that means we've got live updates of real-time quality standards. We might have real-time data collection requirements. We might have all sorts of bits of data that have to go into this process or come out of this process. So those data requirements, that collection of data or the use of data from another source, is as important as any other process, depending on your facility. Period. If you're in a food or pharmaceutical facility, then you will find out that those data requirements are absolutely vital. In fact, you have to throw away product if you can't collect the data properly. If you are in a facility with so basic mechanical systems or process overall, then you'll find that data collection isn't quite as critical. The last two areas I want to talk about for scope are less clearly defined. I think it's critical that everybody understands exactly what the project expectations are, and that those expectations include sort of hard expectations, such as, yes, we're going to get a robot, yes, it's going to do this and that, as well as soft expectations. And so I want to address both of them in this section, period. Hard expectations are ones where you can document it clearly in your 2B, what your future robotic system is going to look like. You'll know what it's going to do, what the input and the output and all that kind of stuff are. You clearly document that. You clearly document the expectations on how fast it's going to run, how long it's going to run, and who's going to manage it. Softer expectations are a little bit less clearly defined. Period. For instance, softer expectations might include that if we have some hiccups, then we'll be able to go through another iteration of the prototype and improve those hiccups. Sometimes a first hiccup or a first mistake on a robotic system, if you hadn't set the expectations properly, will cause that system to be shut down. So you want to make sure that the managers understand that this is going to be a process that could be cyclical and could take a few weeks and a few tries to be perfect. And each time it go through as an iteration, it'll get better and better and better. We also may want to reduce their initial expectations for hitting their target metrics initially. We might say, all right, we might hit that target metric initially, or we might need more time for training. We might need more time for ironing out all the wrinkles. We might need to iron out the reason why on third shift at 3 a.m. every single day it runs, there's just this really weird problem. So you have to let the softer expectations and reduce the overall expectancy that it'll be a perfect system be set in place. The last area that I want to talk about is scope creep. Scope creep is a term that means that you are tempted or encouraged by your boss to do more things on the project than you said you would do. When you're doing a prototype, this sometimes is required. You have to do a little bit more than you said you would do simply to get the thing working properly. However, scope creep that goes and tries to do a whole lot more than the robot was capable of doing, or add on more than you're capable or the people assigned to the project are capable of doing, will soon lead to the project being shut down as well. Scope creep should be something you resist against. In other words, anytime somebody asks you to do something well beyond the initial plan, you might want to push back a little bit. So the last area we're going to get into is taking a step back. And this is going to be a quick little section here. Once you've got your initial plans in place, once you've defined your scope, resisted scope creep, clearly define what you want to do for your work cell, you have to take a step back, period. You have to say, whoa, am I going to be able to improve my overall plant with this work cell? Or is this work cell just going to create one little point in the plant that does super well, but the overall product line isn't affected? Period. This is really important because you don't want to accumulate inventory somewhere in your plant because your small work cell is suddenly churning out 4 times as much product as it used to. So therefore, we start to talk about takt time. Takt time is the time that the product takes to get through production based on the demand from your customers. And so if your takt time suddenly gets twice as fast, but your customers aren't demanding that product twice as fast, you have a mismatch in takt time. You can't just plug it in and go. You've got to address the upstream and the downstream problems if you're improving one point in the overall process flow. And so that's why we're talking about upstream or downstream problems. Sometimes upstream, you'll find that you've got too few parts coming in to support your new production rates. That's an upstream problem. Sometimes you'll find out that you're accumulating product and you don't have places to store it coming out of your production. That's a downstream problem. Both of these can be equally disastrous, and both of these can mean that you've wasted all your time and money on a project. If you find that you do not have a matched takt time between upstream and downstream, and you find that you are not getting an overall process improvement, then you've got to expand your project scope or change the project to match the upstream and downstream requirements. I should say upstream or downstream requirements. So you need to stop your project planning at that point, take a step back, and reevaluate.